And then Claude was not very clear how this progresses, but if I just extrapolate, it's 2026, 2036 or so. So I have about 25 years before what I'm doing has to be useful. And so if it doesn't work out, maybe I'll do something else, retire. So we'll see. But now let me get back to the basics and explain to you really how spin transport and spin currents work. So the first thing is, you have, as most of you probably know, electrons come in two versions, in two flavors if you want so. They can have their spin pointing down, or they can have their spin pointing up. And in most materials, when you do a charge transport, these two spin directions don't interchange that much. So what it means is the changing of a spin is much slower than changing of momentum when electrons transport through materials. And so if you have a ferromagnetic material, you end up with a material that has a band structure that looks very different for spin up and spin down electrons. And this is schematically shown here for essentially a transition metal electron. So you have so-called S bands, which are fairly symmetric, and then you have D electronic states, and in a ferromagnet they're split quite a bit. And so that what you see immediately is that you have different numbers of spin up versus spin down. So you have a net magnetization, that's why it's a magnetic material. And in fact, this cartoon picture is pretty much what's going on. Here you see a calculated band structure for nickel, let's say, and you see you have these S bands, and you have these D bands sticking out, and they are shifted by this exchange interaction. Now, this has consequences for the transport. So if you do electronic transport in a material, all this transport happens with electrons that are right here at these top states, at the so-called Fermi level. And how good the electrons can move depends on how many states there are. If there are many states, they scatter a lot and the mobility is low. If there are not so many states, they don't scatter that much and the mobility is very high. And so if you look at a band structure like this, you see that the majority electrons, the ones where you have more of, have a low density of states here, so they move very well, while the minority electrons here have a high density of states and they don't move so well. So most of the currents here is carried by spin up. But if you have a different band structure, this can be different. If the Fermi level is much lower, let's say here, then these the spin down electrons move very